Good evening, algebra students. I hope that everything is going well. Just wanted to go over our answer key for the Unit 7 practice test in preparation for your test tomorrow. I am going to be talking very quickly to keep the recording short. But do feel free to stop and pause the recording if you need to think about something that I'm saying. And if you still are having some trouble, send me a message in Edmodo, or probably best is to use my Google Voice number, 727-495-MATH, and send me a text that way. And I'll do my best to answer you. I will be not available in the morning before school because I have a meeting. So number 1 asks us, and number 2 is related, so I'm going to kind of be working on both at the same time. But number 1 is asking us to explain why each expression is not in simplest form. And for part A, negative exponents are not allowed. So here I have a negative exponent, not good, no can do. So I've got to fix that. So in number 2, I'm going to take that negative exponent and I'm going to make it a part of the denominator, which exists in all of these quantities. So that's going to become m to the 9th divided by p to the positive 6. So you can simplify that. Okay, for part B of numbers 1 and 2, this expression is not in simplest form for 2 reasons. You still have a negative exponent, so that's a part of it. But in addition to this, you also have a 0 exponent, not good. Okay, so those 2 reasons are why it's not in simplest form. So you need to take care of that. The 0 exponent is going to cancel out because we know that the rule about 0 exponents is that they are equal to 1. They make that whatever it's is being raised to the 0 power is 1. For the negative exponent, just like we did in part A, we're going to make a fraction out of it. That z that has a positive 1 exponent on it right now stays in its place, and the x to the negative 1 goes in the denominator and becomes a positive exponent, changes its location in the fraction, and I'm going to just write it one last time in truly simplified form. I don't want to leave that 1 exponent because that's not how we do things. Part C, again, same problem. It's a negative exponent again. And in this case, I would take it and I would move it to the numerator. And as you know, that leaves me a 1 in the denominator of that fraction. It's still a fraction, but we don't typically write a fraction if it's just over 1. We just write it as x to the 9th, y to the 7th. All right, for number 3, we have a couple of things. This is a little mini megastar combo because I have 3 negative exponents in here and a 0 exponent in the denominator. Just so you know, this 4 in the numerator has an exponent of 1. So it's hard for me to write a 1 here. Whoops. All right, let me erase. Anyway, so there's a 1 exponent on that 4. And everything else is negative, so that's all going to go down to the denominator. So 4 stays on top, and then the denominator is going to become b squared c to the 4th d to the positive 1. And the e to the 0 cancels because it's just equal to 1. So this here is going to be my final answer. I have no negative exponents, no 0 exponents, and I have no double variables. Like I don't have a b in the top and a b in the bottom that I haven't simplified, for instance. So number 4, I'm going to simplify this, and then I'm going to evaluate the expression for 2 different values, and I'll show you how to do that. The 2 things that have negative exponents on the bottom are going to go to the numerator. So let's just do that. So it's going to be 3 to the 3rd power y to the 2nd power. And then the denominator is going to stay just x cubed because that was already positive. So I'm going to figure out what 3 to the 3rd power is. 3 to the 3rd power is equal to 3 times 3 times 3. So that's going to be 27 or 27 because 3 times 3 is 9 times 3 is 27. So this is going to equal 27y squared over x cubed. Now the next step is to substitute in x equals 2 and y equals -4. So this is going to be 27 and then -4, the quantity squared, all over x, which is 2, to the third power. So my numerator is 27, and then -4 squared is actually going to become positive 16. And then this is over 8, because 2 times 2 times 2 is 8. So now I'm going to multiply across in my numerator. So I'm going to do 27 times, just getting let me get my calculator up here. Taking me a minute. You might hear Lulu's little pitter patter of her feet. All right, so 27 times 16. 27 times, okay, operator error. 27 times 16 is 432 over 8, and then I'm going to do that division. So divided by 8, and I get 54. So my final answer is 54, and this is a little bit different than stuff we've been doing because of this part here where it says evaluate for these values. So final answer 54. Make sure that you note that on your test tomorrow. Okay, number 5 is an example of a power of a quotient. So when you get to that last page where you're explaining the rules, the power of a quotient, there's two things that are going on here. I have a negative exponent, so the negative part is going to make me flip the inside. So that's going to become 4f to the fourth over 3g cubed. But now because I've flipped the inside, that exponent on the outside is positive. But the power of a quotient, which is what we have out here, the quotient is the division that's going on inside, means that both the numerator and the denominator are going to be squared. So when I square the numerator, I get 4 squared, which is 16, and then f to the fourth raised to the second power is power of a power rule, so that's going to be f to the 8th, because the power of a power rule is that you multiply the exponents. And then the denominator also gets squared. So 3 squared is 9, and then g to the third raised to the second power is g to the 6th power. And right here, this is my final answer. 16 over 9 can't be reduced. And I haven't left any negative zero exponents, no zero exponents, and all of my variables are written only one time. Number 6 is a straight multiplication problem. I don't know, we've seen a ton of them with double parentheses, but that's what it means. So I'm going to multiply my coefficients. The coefficients are the 4 and the 13. Multiply those together to get 52, just like you normally would not multiply numbers. And then for the variable part, you're going to add the exponents. So 2 plus 4 gives me 6. And this here is my final answer. All right, number 7 is a quotient rule. So I'm going to look at my coefficients first. So 12 over 4, that's going to reduce to 3. And then p to the 9th divided by p to the 6th is p to the 3rd power, because remember we are multiplying, or I'm sorry, when we divide powers of the same base, we keep the base and subtract the exponents. So this is that final answer. Number 8 is power of a power. I'll just make a note here. Power of a power. And the rule is that the power goes to every exponent on the inside. And you have to know that there's, like, the 4 has an exponent of 1. So when I take that 4 on the outside and I multiply it to the powers on the inside, I get 4 to the 1 times 4 power, so that's 4 to the 4th. And then m to the 7th times 4 is m to the 28. So the next step to simplify this, I don't want to leave that 4 to the 4th power because that's small enough number that we can multiply it out. So 4 times 4 times 4 times 4 is equal to 256. So I just simplify that piece out, m to the 28th power. Final answer. All right, number 9 is another quotient rule problem, but in this quotient I see that there is something going on here with this 3 squared. So I'm going to take care of the 3 squared and make it 9. So I'm just going to simplify it. X to the 4th, y to the 7th, over 9x to the 9th, y to the negative 4. So once I have it kind of simplified that way, I'm going to now, the 9's are going to cancel, my coefficients cancel, and then it is subtraction rule. So I get x to the 4 minus 9, that's negative 5, and y to the 7 minus negative 4. So just remember 7 minus negative 4. That's double negative. So that's going to be y to the positive 11 power. Okay, double negative becomes 7 plus 4 gives me 11. All right, so now I've got to take care of this negative 5. That's going to put that in the denominator. So it's y to the 11th over x to the 5th power. And that's my final answer. Number 10, I have a megastar combo is really what I have here. I have a power of 3 on the outside, so I'm going to take care of that power first. So I'm just going to rewrite the first part, so that's 3st to the negative 3, and then 6 to the 3rd power. Okay, remember what I'm saying, 6 to the 3rd power, so that's going to be, I'm just going to calculate it at the same time as I do it. So 6 times, let me clear my calculator, 6 times 6 times 6, okay, so that's 216, and then s to the 12th power. I hope you can see that. All right, so now I'm going to get just straight down to like regular old multiplication. So 3 times 216, because those are my coefficients, is 648. S to the 1st power times S to the 12th power is S to the 13th power. And then the t doesn't have anybody to combine with, so it just goes along. But now my final step is to take care of this negative exponent on the t. So everything that's positive exponent stays on top, and the negative exponent goes to the bottom. So my final answer, completely simplified, is 648s to the 13th power divided by t to the 3rd. Number 11 is an example of power of a power rule, because I have the 4 on the outside, and the power of a power rule is that you multiply. So I'm going to go ahead and multiply my inside. So m becomes 20, 5 times 4 is 20, n becomes 8, because 2 times 4 is 8, and q becomes 16. So final answer, there it is. Not so bad. All right, number 12, Mina simplified this expression, and we have a to the 5th power, because this is the addition rule, because this is, I'm multiplying the same base, so I add the exponents. Power of a power rule, like over here, I multiply the exponents. So I just want to make sure you understand the difference. And then I have b to the 2 power, because negative 4 plus 6 is 2. So then I have to go back. What is the value of n, the exponent on b? Well, the value of the exponent on b is 2. So my answer would be equal to 2. All right, for number 13, I'm not sure if the copy appeared correct on yours, but basically this is kind of like a puzzle. What would you have to put in these little gray boxes to make the right-hand side of this expression be true? So it can be a little tricky, but if you just kind of put your mind to it and think about what I'm saying to you, it might make some sense and help you figure it out tomorrow. I want my right side in part A, I want the right side to equal y squared, which means that I don't want any x's at all. So I'm looking over here at what I have. I have multiplication rules. So if I made this, second x exponent to be -3, then when I multiply those together, I would get x to the 0 power, which is 1, and really kind of gets rid of the x's. Then I would only have y to some power, and I would need that to equal 2. So basically my boxes would have a 2 and a -3 in them. All right, part B, I want my right-hand side to equal 1. So what do I have to have as a power rule? Power rule is that you multiply the exponents. And I know that I'm looking for a 0 because when you see the number 1, I know anything to the 0 power is 1. So basically, if I put a 0 here for my exponent, that would give me multiplication rule. 9 times 0 is 0. N to the 0 power is 1. So that's the ticket. All right, finally, part C, I need one n on the top. So I need the n on the top to be 1 more than 3. So that'll be 4. And then I need 3 additional m's on the bottom. So 3 more than 2 would be 5 n's on the bottom. So basically, what I have on the left-hand side, I'm just going to write it out for you so you see, is m times m. And then I have n, 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 the way I wrote it. This is how my logic, how I came up with this answer. And then I would have m, 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 how many is that? 4, 5 m's, and then 3 n's. My gosh, what did I get myself into? Okay, so there's my m's and my n's, and some of them will cancel. So 1m, 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 1m. And then some of the n's will cancel. 1n, 1n, one more pair, and one last pair. And then all I have left in the numerator is 1n, which is what I was looking for. Check. And 3m, so m to the 3rd power. Check. So just try to think about it visually that way. It might help you with that problem. All right, number 14 is an area problem, and you should know that the area of a square is length times width, or any rectangle has an area formula of length times width. You should know that a square has all equal sides, so the height or the length is 3x to the 4th as well as is the width. So basically, I want to find the area of these. I would do 3x times 3x to the 4th power times 3x to the 4th power. And this actually looks similar to the one that we did earlier with 2 sets of parentheses, but remember that that just means multiplication. So multiplying the 3's on the outside, I get 9. Multiplying the x's on the inside, I have to add the exponents, so that would be give x to the 8th. So just as a note, I'm adding the exponents, and I multiply coefficients. Okay, my final answer is 9x to the 8th. Okay, number 15, I want to see you guys fill this in. You should be able to explain and use complete sentences regarding these properties. The one that I thought might be tricky for you was raising a quotient to a power. And that was, I think, on the second page of the practice test, that one where you had a fraction inside parentheses and it was raised to the -2 power. When you use the power to both the numerator and the denominator. That's what that's all about. So just kind of keep that in mind when you're answering these questions, but I'm going to leave these up to you. I hope that was helpful, and just as a reminder, my Google Voice number is 727-495-MATH. Feel free to text me if you have any questions or send me a message on Edmodo. I wish you the best of luck. I will be available during lunch if you have any questions. A lunch is my lunch, so have a great night.